Hello everyone, welcome to our Community Friday, number 6 actually. So my name is Mimi, I'll be your host today. I'll just go through the usual structure that we have. If this is your first time joining or the 6th time joining, so we have some house rules. We'll show something that we shipped in the past couple of weeks, something that we've been kind of struggling with and still working on. And we, of course, will try to demo it to you so that you can actually see. Today's rough agenda is we'll start with our hardware team, and then we'll move on to our very special guest this week, but I'll speak more on this later. And then, of course, we'll wrap up with our usual housekeeping, career opportunities, and also some actually very exciting events that we've been hosting this month. Okay, so I'll pass on to Jashan.
Hey guys, it's nice seeing everyone after 2 weeks. So I'll be starting off with everything we've been doing. So our goal for this week and actually for the previous week as well is that we want to stabilize the robot as much as possible, especially on the software side. So I mean, usually in software we talk about what the code we're writing, but actually what we're concerned with over here is the OS itself and whether our software is interacting with our OS in a functional manner. We've been having some issues with our robot communication. So about 1 out of every 20 runs of the report, we have some weird CAN interfacing issues with some either RX fails or TX fails. And me, Ishii, and the rest of the team have been working very hard to narrow this down. So after a lot of debugging, profiling, staring at D message, if you've done it before, we've managed to optimize the core such that it only fails about maybe 1 every 30 runs right now, and we're able to actually recreate the problem very reliably. I'm bringing this up because being able to recreate the problem is the next step to actually solving it. So we believe it can get solved soon. So on our current stage of where we're at in our debugging process, we just managed to do some kernel tracing of the SPI to CAN driver. And what we noticed is that occasionally when CPU load increases, the packets arrive out of order. So we're not 100% sure why this happens, but it is happening. And over here is a snippet of the kernel trace that we got. And you can see over here, it's showing that it's happening from the RxIF CAN handler. RxIF in this case here stands for receive first in first out. On the native CAN, which should be more stable, we've actually been seeing crashes as well. And this we've narrowed down to, for some reason, the bitrate is no longer being set to 1 megabit per second, even though that's what we've always been setting it at. So this could do with hardware degradation, maybe a wire is loose somewhere in our setup. So we're going to go recheck all the wirings. For those of you who were here last week, you would remember that we are working on a new board as well. And it should be arriving today, actually. If it arrived before the event started, I will show it to you guys physically, but it's still on the way with UPS. So hopefully that helps with the signal integrity issues as well. Well, hopefully 2 weeks from now we have better news. But Ishii, I think it's good to show what our debugging has resulted in.
Can you see my screen? Yeah, so I'll go ahead and I'll go into what we have done on the policy/training side. So first I'll start off with last week, the last Community Friday where we ended off, we actually got to a stable point where the locomotion policy was good enough such that the behavior was reproducible and we were able to get consistent output when we were walking it or we were tugging it at balance. And then after that, one issue we realized as we are scaling up for manufacturing of the DIY kits is that the toes have a hinge. And that hinge is not a standard hinge that is available and actually has to be tensioned and tuned. And that adds another layer of complexity because now you suddenly have a lot of robots and maybe the tension is not the same in all. It could result in different behavior. And also, it's an additional step to add in the simulation. You have to model the toe, you have to add the toe to the critic as well. So taking all of these factors into consideration, we decided to go ahead with the fact that, okay, let's remodel a foot. And Alejandro actually came up with a smaller foot design without the toe. which would be easy for us to manufacture as well. And so for this, then we had to remodel it in simulation, and we found that a more elegant way to do this is by just representing it with four spheres. So I think last time, if you remember, I showed that it used to be modeled with foot capsules, like long cylindrical capsules, but now we just model it with four spheres because all the robot just needs to know is, okay, is the front part of the foot in contact with the ground or the back part of the foot in contact with the ground, and you can actually reward it so that based on these contacts, it can actually walk. So we remodeled it, and then we got to a stable locomotion policy. And with all the hardware debugging and making the robot communication more stable, making sure there are no background processes running on the motion control board, we actually got it to a good point that we were able to bring it outside. So if you can actually see, we are bringing it outside, and we're actually controlling it using this controller over here. So it's an 8-bit DO controller, and this actually helps us to correct drift in real time. So a robot is actually drifting and it doesn't walk straight. But now, if with the controller we are able to send it your command as well as a walking forward command. But if you see in this video right here, one of the main issues we are still trying to understand is the robot is sort of limping on its right leg. This behavior is seen in simulation as well, but we believe it's more pronounced in real. And so what we're trying to understand now is, okay, is our vanilla RL pipeline over tuned to like the foot, or over tuned to like just these rewards, and it's just learning a dynamic where it's limping. And so one thing we need to do on a software slash training side is actually try imitation learning. So we want to try out and start out with a very simple one, which is just squatting, because in this you're just rewarding the model to just actually output the same joints with physics. And so we know that the learn dynamic in this would be much more consistent, and we will actually know that the policy will learn the right thing. And then we can actually cause it to limp. And so this is what we are doing now. We are testing a scoring policy, and this will help us to not like overfit to just vanilla RL reward tuning. And also, when we brought the robot outside, we were able to actually bring it to a coffee shop, um, on like the second floor in a building. And this was a good milestone for us because we will stress test the robot a lot. It entered the lift, we controlled it. It's fully done via Bluetooth. So we launched the firmware with System D, and then we can just connect this controller via Bluetooth, and you can bring it outside. And if the controller disconnects, you can reconnect. So we're just testing a lot of quality of life measures to bring the robot outside and make it be able to walk in events, etc. So these are the results from a lot of our hardware debugging as well as the software debugging, and some considerations we made on our end to remodel the tool.
Shall we answer a few questions?
Yes. So a question from Wilhelm Chrisman. I'm sorry if I pronounced the name wrongly. But dropping packets on higher CP load. Are you guys running on RT Linux? So currently we're not running on RT Linux. We're currently figuring out how to get the RT Linux patch on our chipset, the RK3588. But what we wanted to do was to profile everything first so that we can understand that when we do move to RT Linux, which will happen, exactly how should we place our threads and our processes to fully maximize it. Yep, exactly. So we are already doing this on our current implementation, even though we don't have RT Linux. We are able to set everything except our hardware interrupts on the SPI CAN lines to be on any core we want. So we've played around moving it about, and we found a certain combination that gives us the greatest reliability. But now we're trying to really nail down that last 5 to 10% to get it to 99.9% reliability.
If you guys have any more questions or comments, you can just leave them first below and we'll respond or like come back to them at the end. But in the interest of time, I would like us to move on to the next section, which we're all very excited about. We have a very special guest today. So our guest today is Menlo Gomez, who is actually a man of many titles, I'd say. He's a technology executive, an entrepreneur, and a robotics builder. So Mando has led engineering teams at companies like Yahoo, Amazon, and X, and today he's been building our Asimov in his garage actually. So he has very kindly agreed to join our session today and would love to share a little about his journey. So if you have any questions or comments for him, please also leave them in the chat. But yes, hi Mato.
Hi, everyone.
We're very excited to have you here.
Yeah, so maybe a little bit of context, how I discovered the project and why I decided to kind of build it in my garage. So let me share my screen. So a few months back, actually probably maybe in September last year, October last year, I was looking into different open source projects, and maybe some of you might recognize this robot. It's basically the KScale KBot, and I was very curious and interested, right? So actually, I went to their offices in Bay Area, and I was in their waiting list, waiting for the robot to ship. And unfortunately, this company went out in October, November, and I still wanted my humanoid robot. And that's basically by looking different robots and all of that, I stumbled upon Asimov, right? And I was very excited to see the different things. I got the other step file for the legs, and I started analyzing it, and I was comparing the different open source projects, and I really like some of the things. So I was looking in the hardware that I have at home, so in that way I can manufacture some of these parts myself. And that's basically how I started the whole process. The last 3 months or so, I have been learning metal casting, CNC, Fusion 360, and so on. So I don't know what questions you guys have.
Maybe you could mention a little bit more about your background and how hard or easy it is for you to actually build the robot, because I know our community members would be interested in building it from scratch, but how realistically, how hard is it?
I can tell you that there's a lot of disciplines that you have to know. You basically need to know a little bit of 3D, but I can tell you that you can learn. Right now with maybe even I can show you a little bit on my screen. Let me stop sharing here and I'll share another one. Now with Claude or Cursor actually can help you out to, let me even share my whole screen so I can go back and forth. So basically with Cursor, you can even connect it with Fusion 360. And you can say, hey, by the way, can you help me to do this? It's going to burn a lot of tokens. It's going to be a little bit pricey. But at the end of the day, it's going to do it for you. In some cases, actually has helped me because one of the things that you guys have done is that some parts are very well documented. But I actually stumbled into a problem. I ordered it in January from a different company. Let me actually have here and by the way, they are not a sponsor or anything. This company is called My Actuator, and they were the cheapest ones that I found so far. I didn't know about Encos. If not, probably I will just go with them. But I got 3 different actuators, and I have some of them here. By the way, they are heavy. One thing that is interesting about these actuators is that it has like these notches, so that way it's not a full circle. So I kind of like it though. It becomes a nightmare to be able to kind of strap it properly because it's not a circle. And we have another one. So basically, this one that is an X436 that also is very similar to the ones that we're going to use on the Sheen. I want to show you kind of a little bit of the progress, right? I already have the 2 legs. One is kind of complete. I have it at the bottom. But I already, unfortunately, you guys are removing the toes, and I actually did the toes. So it has the different parts, has the ankle, it has the different sections. Some of the pieces that you see here, I machined it because the bomb was released a couple of weeks back, but I started to machining them. Maybe a couple of questions were asking about how difficult might be to do it and realistically to do it by yourself, I've been doing it. Everything that you see there, I have been doing it by myself. The only thing that you need to be aware, let me share another one. And you can go to my channel, and I'm posting is TechMex, and I'm posting a lot of the different things. The tools that you might need is basically, let me just put in the mute here. You can learn a little bit of sand casting. And again, I'm doing it myself. I'm in the community. If you guys have a bunch of questions, you guys can ask me. I'm learning a lot about CNC, but there is so much information out there, and the files are there that it will be straightforward. And ultimately, yes, it's a lot of kind of work. If you want to wait for the kit from these guys, sure, go for it. In my case, like I said, I have 30 of these actuators. I didn't want to waste them. So that's the reason why I'm modifying a lot of the designs that in order to be able to hold these actuators.
Yeah, thanks so much for working on this one though. It's really cool, especially the casting part. We didn't think someone would actually try and cast it because the part is we 3D metal 3D printed it, right? But casting actually
Uh,
makes sense. You're able to get the same geometry.
Today, this is something interesting. I actually I posted this. Um, this is the one that I did literally today. I'll post the video, but basically it's the kind of the strap. I know that you guys have it like with a gap here, and I think that I have it on the Fusion 360. Let me see here. Maybe one of these. Yes. So um, again, my actuators are there a little bit bigger, but this is basically kind of the redesign, and that's one of the shout out for you guys. The design is very easy to modify. You guys have the parametric design, then you can just open it on Fusion or OpenShape or any other or SolidWorks, and can be modifiable. Um, Between, I guess the tools that you might need is CNC. I have been using a Carvera, and I have a Carvera, which is the desktop one, and I also have a conversion of a mill. This one is a Chinese mill called the G0704, and I also robotized it. Basically, I made a CNC, just a regular mill, but I made a CNC. Again, I have videos in the channel to be able to do that, and then you are able to do that. But if you don't want to get that big of a machine, you can get a Carvera, and I think that I have another video. Yes, this one. So here is a kind of a snippet of the Carvera. It's gonna take a while. I think that this part took like maybe 2-3 hours to make this part. But as you can tell, these ones are part of the bombs. Maybe you might not want to to build it yourself. You can just buy it from GoBuild. That's the company. But I actually even got the bearings, and I literally just with pressure, I put it there to preload them and press them. So I guess you need a CNC, whether it's a desktop like a Carvera. And the other thing that you want to get, and that one is a bit more pricier, is a SLS machine printer. I think that I have a small video here, and the problem is that that is a bit big. I was also looking into a different projects like the SLS for all. That's the name of the open source. Let me see here. And the reason why you want to use that is because this material it's very resistant, and but the problem is that it's powder. So yeah, thank you for switching me. Yeah, thank you for switching me. So it creates this grainy feel, but it's very resistant compared to PLA or other plastics or other materials. So and again, right now this is my garage, and I don't have all of the equipment. If you want the whole equipment, it's gonna cost you maybe 50-60K. But you will not believe this. I actually found a used printer in Facebook Marketplace, and it's just like it was pennies of a dollar. Anyways, I'm using 4 labs. nylon 12. And you have to be very careful because this material is powder, right? So you obviously do all of the precautions there. But once that you kind of have it, then the printer is like almost like almost very similar to the bamboo slicer. And the only thing that you have to do for this is that you have uh, to use a mesh. And one of the things that I'm doing, for me, is very interesting the tinkering of all of these challenges. Sometimes I have to build a tool to make the tool to actually do the part of the robot, right? So in this case, this thing that you are seeing here is a sifter that I got in Amazon for $150. If I got it from Formlabs, I'm sorry, Formlabs, it would be $13,000, right? Just to do that, like it's just a sifter. You just need to 150 mesh, and yes, I have a respirator because it makes a mess. But once that you do that, then the powder is ready to be able to put it on the machine. The machine is almost like a mini fridge, so it's kind of big, but it's quite nice because actually it's sintering with laser. And that's pretty cool. I have lasers in my garage, basically, doing parts, and you can see on the camera, kind of doing the sheen, right? So, and once that you finish, you can just pull it out, and it builds this kind of like a cake, which that was the other thing. Formlabs sells you another system to be able to push a button, leave the cake, and then you can get it out and do a recycling of the powder. Or in this case, my method is a bit ghetto, but it works. You just basically dump it into into this bucket, right? And then you have this cake, and you just break it apart. And literally, that's what I'm doing here. And I'm just breaking apart, and it's literally just with a brush, and you're cleaning kind of the part. And ultimately, that's what I did for all of the parts. One thing that to notice is that this printer, the size is only up to 30 centimeters. So basically, some parts are larger than that. So I redesigned a little bit this part to be able to have a dovetail. We'll see if it breaks. If it breaks, obviously, I'm gonna have to just maybe order it from another supplier that can have a larger printer. But yeah, I redesigned it to that. And here is kind of like a little close up on the dovetail. And I was able to actually put it on the bottom. Let me see if I have I think that I have yes. I put some screws to be able to have some mechanical I guess load on the part. So that way I'm able just to press it. But yeah, what questions do you guys have?
For the powder clearing thing, could you use the same system? Like you just toss it in there, it rotates, right? Would that work?
For what part?
Or for when you were clearing out the thing by hand, right? Could you use the same machine you used with the mesh in the beginning?
And no, because I will have to let me show you this thing. What it happens is that the powder, sometimes because it's so fine, it clumps. That's literally what happens. And Houston is very humid, like all of this area. So even if because I'm in the garage and it doesn't have AC, it clumps. So literally, when I want to start printing, I kind of sifted this. And the other thing that happens is that because I have the cake, you can reutilize a lot of the powder because if not, you waste. Like in the traditional FDM 3D printing, you have like the supports. Over here, you don't need support because the powder is acting as support. You can reuse that powder. So the Formlabs recommends you to have about 30% mix between your previous powder and the new powder. Then that's what you want. You want to sift it, both of them, and then mix them in that ratio. And then, yes, I will have to make a machine just to kind of clean it for me, which actually Formlabs also sells you. So basically, there are three machines that the whole kit is like 60K, and it's 50K a pop, right? So for me, right now, we just a brush because I'm not doing mass production. But if I would have to make a mass production, yes, I would have to make a tumbler, basically, and then maybe with sandblasting to be able to have the kind of the part just tumbling and clean out the part.
Yeah, that makes a lot of sense. I mean, what's the first thing you're gonna do once you build your robot?
First, I wanted to do the typical things like walk and kind of the locomotions, right? But ultimately, it's like the dishes, right? Like go and do the dishes. That's basically, if you can do that, you can do anything. So I always have the fascination for robots. When I went to college, uh, we were doing a biped, and there was this contest. It was called Walking Machine Decathlon, like 18 years ago, and we actually in that time we were building our own PCB boards. There was no PCB way or whatever. Um, there was no YouTube in that time either, so everything was like books, right? And so on. So we were able to no actuators. We actually came up with our own. We actually disassembled Black and Decker screwdrivers and removed those motors, and then use that in order to power our first robot. The thing only did like 2 steps, but it can. That's the only thing that we were able to take it. And then we also did a spider. That one walked, and we actually were able to get a good position on the board. But yeah, my fascination has been many years. To be surprised, right now I took it over. I have been in the tech, more in distributed systems and software. And for my surprise, not a lot of things have changed. It's like, man, this is like very similar. I'm able to get a lot of the knowledge that has been there for almost 20 years. Yes, we have AI, and that's actually great. But a lot of the principles is still there. You know, you need the actuators, you need electronics, you need the brakes, and blah blah. So I will encourage everyone to do it. Maybe not as crazy as me to do everything. But you might be able to buy some parts, right? If you want to do this, maybe get some parts. Obviously, you can get the kit from Menlo Labs, and but yeah, it's good. The challenge is good.
Yeah, I think I can resonate with the fact that robotics has not changed much. Like, I mean, there's obviously been advances, right? Algorithms and I mean, compute getting better has also helped a lot of things actually be implemented. But the fundamentals are still the same, which is, I mean, it's nice as well, right? And you know that there's always going to be some carry forward of your knowledge, even with AI and everything coming out.
So I see somebody saying that I'm living the dream. I I really think that just having a bunch of tools are expensive, right? I'm just buy them used. Let me give you an example. The kiln that you see is pretty big, and if you buy it new, it's about $8,000. I paid $200. Somebody didn't want it because it's huge, right? And it's like I literally went. That's the kind of the nice thing of living in a very cosmopolitan city that you like. There is a lot of people, and they just wanted like to throw it away. It's like basically for free, right? I got it, and sometimes it's broken. That one it was broken, but I got a part. I obviously know how to fix the thing, so then I changed the board, and literally just couple hours, and I was able to fix it, and that thing is helping me to do the metal casting, which I also enjoy as well.
Okay, so I'm very mindful of the time. I know it's a very really good conversation. I think Mando, you're on our Discord, right? Can people reach out to you over Discord, and if they have any more questions?
Yeah, just ring me on Discord or DM me or go to my channel. I'll be adding more videos there.
Okay, fantastic. We'll leave the links for all your contacts in our comments. In the meantime, I think if Herman can do very quickly promo for our career opportunities.
Okay, hello everyone. My name is Herman. Very nice to meet all of you again. So, same thing, it's the same spiel for me again. So, we're hiring lots of roles right now and currently open. We even have a role open in San Francisco. So, we welcome any and all applicants, and I look forward to meeting each and every one of you and talking to you as well. So, thank you, everyone.
Herman. And actually, speaking of the United States, the past week or so was very exciting for us. So Dan and Nicole are in the States at the moment, and we have been hosting a lot of offline events. Let me share my Luma event page. So we've been hosting a couple of events in Palo Alto and San Fran. On June 2nd, and actually just now. So Dan and Nicole have been meeting a lot of you guys in person. I think the Palo Alto event was ended up being a picnic event with over 300 people attending. So that was very fun. And upcoming events, we have one in Austin and one in London on June 10, and the Austin one is on June 6th. So if you're around for any of those events, we would love to meet and connect with you in person. Also, please do sign up early so we can secure venues. We want everyone to be safe and comfortable, so we need to know how many people are attending. Other than that, yes, we'll leave all the links in the comments so you can check them out yourself. And also, as usual, please feel free to contact us over our socials, tag us if you're building the Asimov, the usual. And I think on that, we can end the event because we're a little bit over time. Thank you, Mando, for your time, and thank you for joining us. We really, really appreciate your work.
Thank you, and thank you for all the community.
Thank you, guys. And that's a wrap.
All right.